Alright, this video is going to be done in two parts. The first one is going to explain the first two problems and everything else, and then after that we will figure the next parts out. I'm hoping I don't have any obliques in here. If we do, then we'll worry about that at that time, and we'll go from there. So the first thing is rational function is two values that are division where polynomials and your denominator cannot equal 0. Your vertical asymptotes are whenever your denominator equals 0. A lot of times you can mimic them to state they are like your h values and k values in standard form. Horizontal asymptotes have at most 1. So you do have certain scenarios that can happen where items are obliques and things like that. And that's going to be question number B on the front. We will talk about it, but we're not going to do it. If the degree on the top is bigger, then there's no horizontal asymptote. If the degree on the bottom denominator is bigger, then it's at y equals 0. And if the degrees are the exact same on the numerator and the denominator, we take the leading coefficients. Oblique asymptotes, a horizontal asymptote that is neither horizontal or vertical, slant, obviously, obliques, is when the degree is bigger on top be by more than 1. By 1, you must do long division to find it. So if it isn't bigger than by 1, then you don't need to find it. Points of discontinuity. Values are going to cancel out. We're going to have to factor. When things cancel out, asymptotes that were originally vertical become holes in the graph because they simplify out, but the values still cannot exist. So there's an example of what it looks like. Excuse me. And then we're going to go through and do this, okay? So the first thing you do is you factor. And if you can factor anytime, we're going to factor. On the top, there are no factors of 2 that add up to be 0 that are natural numbers. So we're just going to factor the bottom. We're going to get x plus 1, x minus 1. And we're going to leave the value on top as x squared minus 2. Excuse me. So to start, vertical asymptotes. Your vertical asymptotes are going to be at x equal to negative 1 and 1 due to those two denominators being equal to 0 by plugging those values in. And then to do your horizontal asymptote, we're going to look at the original problem of x squared divided by x squared. Those powers are the same, so the coefficients are going to lead to 1 divided by 1, which means I have an asymptote at y equals 1. So this graph has that. There are no points of discontinuity because nothing cancels out. And on this question here, we have a difference of the higher degree on the top by more than 1, so we don't have any obliques, thank goodness. We're going to start with the denominator. You have a vertical asymptote at x equal to negative 2, the opposite of what you see. And then what we're going to do is we're going to come back here and we're going to reread up here. So if the degree of ax is greater than the degree of bx, there is no horizontal asymptote. If the degree on top is bigger by 1, you must use long division. Well, not bigger by 1, and how do I know that? Is I'm going to compare x cubed over x squared, or x, excuse me. And because since the numerator is bigger, then I have no horizontal asymptote. Okay. And what we're going to do now is we are actually going to go graph both of these. So, welcome to split range and non-split range. So on this first one, we're going to go graph the functions from above. So I'm going to take my asymptotes and I'm going to write them in. So I'm going to start with this, and it's going to be at negative 1 and 1. And what we're going to do is we're going to go by 2s. So I'm going to have negative 1 be 2 blocks out, and I'm going to have 1 be 1 block out. Negative 2, 2, 3, 4, 5. So same thing, negative 3, Move over 2, -4, -5. It's going to give you just a little bit more room. I went a little bit too far. Let's try this. -2 should be here. -3 should be here. -4 should be there. There we go. -5. So I'm going to have an asymptote at -1. And +1. Remember, I'm going by half steps. And then we said I had a horizontal asymptote at +1. So I'm going to come up here, and we're going to do those by ones as well. So +1's going to be here. Okay. And what I'm going to do is I'm going to go type this in my calculator. So original problem, parenthesis, x squared -2, close parenthesis, divided by, parenthesis, x squared -1, parenthesis, enter. And I'm going to hit graph. And what you'll see is you will see lots of fun stuff going down. Okay, so I have a split range. So this has us doing a lot from the very beginning. Welcome to math. So the first thing we're going to do is we're going to look at our graph, and we're going to say, hey, I have a min or a max. And so with that, we're going to calculate things out. Okay, and so I'm going to make a table in purple. I'm going to go x, y, and you only need to have 5 points. So the first thing is going to be the point in the middle. I'm going to calculate out my min. So I'm going to have a minimum here. Okay, so Casios, you're going to have to remember how to calculate out your values. Second calc, min of 3. And what you have to do is you have to arrow over until you get onto that min. Okay, and you still have to go on the left bound. Okay, I'm going to hit enter. And then I'm going to go through the right bound, come here, enter, and it's at 0, 2. Now the cool thing about that 0, 2 is that is also your y-intercept that you are supposed to have. So at 0, 2, remember we're going by scales of 2 boxes equal 1, because this is 1, 2, 3, 4, 5. All right. And what I'm going to do is I'm going to have to then find points on each side of that. So I'm going to go second, table, and I'm going to arrow up until I get to 0, 2, and it's not showing me anything. That's a little bit of a problem. So what we're going to do is we're going to go second, calc, and I'm going to find a value. I'm going to hit 1, and I'm going to type in 0.5, enter. And so now I have negative, oops, wrong color, negative 0.5 and 0.5, because it's going to go on both sides, and I'm going to have 2.3 repeating, because they mirror each other from when we did parabolas. So at 0.5, 2.3, it should be a little bit higher than that, because I'm going by half, so I forgot about that, 2.3, and 2.3. Because 2.5 is in the middle. No big deal. And we're going to go up. And we're going to go up. Whoops. That's fine. It's not perfect. It's okay. And then what we're going to do is we're going to go to our table. And this is a really easy thing. Is on each side of the air, we're going to find 2 numbers that match. -2 and 0.6 repeating. And 2 and 0.6 repeating. And I'm just going to plot those points. So remember 2 is out and 0.6 is going to be a little bit higher. So 2.6. And then I'm going to mimic it on the other side. So over 2.6. And I'm just going to draw a curve. Doesn't have to be perfect. I'm not looking for perfectness. Going to come down and go like this. And going to go up like this. Done. Come down, mimic, and go this way. All right. Domain and range. Domain and range is really easy. Promise. Domain. on your graph. You're going to start coming from the right side. Hit the asymptote, can't be that value, but I could jump over it, and then I become a new value, and jump over it, and then become all these values. So I can do every value of x, except for my asymptote, so all real numbers. Oops. X cannot equal my asymptote of -1 and 1. Range, however, on the other hand, is way different. So, on this question, you have values going above and below the graphs. Where your min and max is, we'll talk about that second. The first one is your values of the asymptote. You have y, and your asymptote is at 1. My values are less than 1. They will never touch 1, so they cannot be equal to it. And you also have your values here. So this chunk here does not account for anything at a certain point. Oops, too far. From your asymptote, okay? So your graph does not start above right at 0, unlike the other ones we were doing. This one starts slightly higher. So where that min is, or the max, you have a domain and range that has to be accounted for. Domain's already been accounted for, but your range has not. So at that value, you have y, and the min is at 2, but in this case, I'm getting bigger and equal to 2. There you go. That's one question on the test. This one over here, we are actually going to skip to that, but I do want to show it on the calculator. But due to the scaling and everything else, I just want to get to the next part, so then you guys can work on your homework. So we would go x cubed divided by parenthesis of x plus 2. And if you hit your graph, you would have a funky loop thing. Okay? But then what happens is you have a hole at 2 because of an asymptote. So when you go to your table, you have an error at -2, but it goes through the graph because you don't actually have a horizontal asymptote, so it's just a point of discontinuity. And so what you would have to do is you would have to calculate it out and everything. So with that, we're not going to worry about it because that one is not on the test, but I did want to talk about mainly this part here. So turning the page, we only got 3 more graphs to go through. Okay. We are going to skip question number 1, or question C, because that has an oblique, and I'll show you what an oblique looks like. So you have 6x squared, so I put that in parentheses, 6x squared minus 3x plus 2, all divided by x, and we don't want to do long division. Like, I like long division, but even I don't want to do it. But when you look at your graph, what happens, I'm going to zoom out, is you get an oblique thing. So you have asymptotes that go up and down, left and right, and then you have a slant. And because of that, we're not going to deal with it. So we're just going to skip that. Okay? So we're going to skip. And as I said, you're going to have videos to help you with your homework too. So that's why it's a 2-part thing. So what we're going to do here is we're going to look at this. And we're going to go to y equals, and we're going to plug it into our calculator first. With parentheses, if this has an oblique too, I might just cry. We might have to just jump to our homework. I did homework first last night, so if that's the case, then that's what we'll do. But I don't think it has an oblique. I'm hoping it doesn't have an oblique. Oh, no, it does have an oblique too. Yeah, we're going to skip this one as well. We're going to skip all these because these all have obliques. So, with that, we're going to jump to our homework. So, I'm going to end it with this video here. Great job copying on the front. And I need to get those problems changed for next year because that ain't going to work. So, we will see you on part 2.